the general syntax for loops in Java can be found down below. So for int var, var is basically a variable. It can be I, j, k. This can be anything, but we usually use I, j, and k, or you can name it anything you want. It's just a variable name. And then we have the starting value, so the value that the integer is going to be starting at. Then we have the variable name over here again. I used I as an example. Sign, and then boundary. We'll cover these more in depth later. And then we have the incrementation. So let's start with a general overview on each one of these in a bullet point. So we have the variable. It can be anything, like I said. We're going to take I as an example for the rest of this video. So whenever I refer to I, I'm referring to the variable. Then we have value. Value is the initial value of the integer on the first traversal. We'll cover that more in depth later. Then we have the sign. Sign, it's the sign that indicates the boundary's direction. So either upper or lower, or inclusive or exclusive. And then we have the boundary itself, which is the maximum or minimum value of I, the variable. And then we have the incrementation, so how I is changed before or after each traversal of the for loop. So let's go more in depth into each one of these points. So the syntax details for value is that it can be declared in the for loop, like so. So I is just an example name, like I said, int I equals 1. Or it can be declared outside. So for int I, we can name the variable which is declared outside of the for loop. Now, when do we use it inside? When we declare it inside, and when do we declare it outside? Most of the time, we're going to be declaring it inside. However, in cases where we want to perform some certain manipulation on the variable before entering the for loop, we declare it outside. So such cases could be accepting the variable as user input. So if we were to accept the variable as user input, we'd have to declare it outside. So user input equals whatever scanner object we're using. And then we'll do the for loop and do int I equals user input. And then etc. So that's like for the introduction course, that's mainly the only case where we're going to be using the declaration of the variable outside of the for loop. There are other cases moving forward. However, this is the only one we're going to be covering in this video. It can be done outside anytime. However, it's much easier to do it inside, and the only time you need to do it outside is in this case, because it'll cause an error if you were to declare it inside while accepting user input. Silent incrementation. Silent incrementation are one of the most important points in the for loop, and they define a lot about the for loop and what the use case of the for loop is. So the sign indicates whether the boundary is upper or lower, and whether it is inclusive or exclusive. So there are 4 valid variations of silent incrementation. There's I greater than or I greater than equal to both paired with I minus minus, I less than and I less than or equal to both paired with I plus plus. So why are these the only valid ones? Let's discuss one example where the variation is invalid. If we were to have I greater than 0, for example, and the starting value of I to be 5, paired with I minus minus, or for it to be invalid, I plus plus. So we know that with an I plus plus, after each traversal of the for loop, the value of I is going to increase by 1. We go from 5 to 6 to 7 to 8 to 9, and we just keep going on, causing an infinite for loop, since the only boundary is that I is greater than 0. If we were to have the correct syntax, which is I minus minus, it would go down from 5 to 4 to 3 to 2 to 1 and stop, since it can't go down to 0, since it has to be greater than 0. So now we know why we can't use plus plus paired with a greater than, and we have to use minus minus when using a boundary which is greater than, because of the infinite for loop bug that we might have. So some of the common uses for for loops in the introduction course in exams are pyramids and string traversal. So pyramids like the one shown here, and string traversal problems like profanity filters. We'll be moving on to Visual Studio now in order to show some of these problems in action and solve them together. So here we have our first Java program, or question. It says write a Java program that calculates the sum of integers from 1 to 30. we're starting off with these kinds of problems in order to get a grasp of how for loops work, and then we'll move on to more exam type questions later on. So write a Java program that calculates the sum of integers. So the objective is to calculate the sum of integers from 1 to 30, which is 1 plus 2 plus 3 plus 4 and onwards. How do you do something like that? First things first, let's make an integer variable called sum and set it to 0 at first. It's empty, we didn't begin adding anything to it. Now let's make a for loop. We want to begin adding integers from 1, so we'll start I at 1 all the way up to 30. So here we have a choice. We can either do I less than 31 or I less than or equal to 30. Both work. We'll just stick with less than or equal to 30, and then we'll do I plus plus. Then in here we'll increment, or we'll add the current value of I to the total sum. So we'll do sum plus equals I. What this does is it fetches the current value of the sum. So on the first traversal, that's 0. It adds 1, and then the value of sum is now 1. Then on the second traversal, it grabs the current value, it adds 2. Now the value is 3. Then on the third traversal, it grabs the current value, which is 3. It adds 3. Now it's 6, and so on. And then at the end, we need to output to the user. Run, and we should get 465, and there it is. Alright, so let's move on to our first exam type question. Over here, we have a question that asks us to make a program that outputs this pattern over here for any n number of lines. So to begin, we'll first cover an approach that we should be taking with all for loop questions. And to do this, we need to first find out what the program needs to do behind the scenes. We can see here that we're starting a new line every time, and we're printing a certain number of stars. One thing that becomes apparent is that the number of stars is equal to the line we're at. So if we're at the first line, we want to print 1 star. If we're at the second line, we're printing 2 stars. Now, to find out how many for loops we need to identify the number of repetitive functions. So we have 2 repetitive functions here. The first is starting a new line, and the second is printing the stars. So we need 1 for loop for this one and 1 for loop for this one. And obviously, the starting line for loop would be the outer for loop. And we'd have the one that prints the stars inside of that for loop. And then we'd have each one's respective code inside of it. So let's move on to how we're going to code the actual for loops themselves. We won't move on to Visual Studio just yet. We're gonna first cover how a general overview of how the numbers or how the code is going to look through numbers first. So for the outer for loop, let's say we start at I equals 0, and since we know that the outer for loop isn't going to be executing anything, the only thing it's executing is the for loop that's inside of it. It only needs to repeat equal to the number of lines. So we want the outer for loop to repeat 4 times. So what we'll do is we'll set I equals 0, and we'll make the upper boundary I less than 4. Or for later on, when we're making it accept any n number of lines, we'll make it equal to the user's input of n, let's say. But for now, let's stick with 4. So we'll make I less than 4, and then I plus plus. So why is it less than 4 and not less than or equal to? Because we're starting at 0, then going to 1, then 2, then 3. So that's 4 different lines right there. If we go up to 4, it's going to be 5 lines. So we just want to make it less than 4. Again, let's write out what the code is doing so far with just the first for loop. So if we made this our first for loop, let's write out what's happening under the hood per se. So we'll say 0. Then the second time, the value of I is 1. Then the third time, the value of I is 2. The third time, the value of I is 3. Or the fourth time, the value of I is 3. And every time it's stopping, it's executing a certain function, You know, on each traversal, it's doing that. You get the idea. Now we can move on to the second for loop. So let's start by making it ascend. So logically, when we're looking at this, as we mentioned, we're printing out the same number of stars as the line we're on. So 1 star on the first line, 2 stars on the second line, and 3 stars on the third line, and so on. So what we can do here is we can fetch the value of I and make it equal to the value of the for loop that we're on. If the value of I is 0, we'll make it go down, or we'll increment j downwards and make it meet the lower boundary, which is also going to be 0. Okay, I know this doesn't make sense so far, but when I write down the numbers and how they look, it'll make more sense. So we'll do the inner for loop and make it for int j equals I, j greater than or equal to 0, and j minus minus. Now what is this doing? Let's write it out. Okay, so what we'll do is we'll go over here, we'll do first traversal. This should make everything clear. On our first traversal, I is equal to 0. J is fetching the same value as I, so it's also equal to 0. Now what's happening? We're going into the I for loop, then we're going into the J for loop, and what's happening in the J for loop is it's executing 0, then it's going down to -1, therefore it's not actually going into the loop, so it's just doing 0. Then on our second traversal, I equals 1, therefore J equals 1. We're going into the I for loop, which is starting a new line, and then into the J. We're starting 1, then 0, then we're stopping. Now let's do the third traversal. I equals 2, then J equals 2. We're going into the I for loop, starting a new line, then into the J, which is doing 2, 1, and 0. Now, we can see a certain pattern coming out with the numbers. If we visualize these numbers as stars, we can actually start seeing the pattern that we want right in front of us. Over here, if we write them down next to each other, you can see that we can kind of see the pattern right in front of us. And then for the fourth traversal, it would be 3, 2, 1, and 0. Now, let's go to Visual Studio to see how we would code something like this. Okay, now we're back at Visual Studio. So let's set up the user input first. We'll just make a scanner object. First, let's import the necessary utilities. And we'll make our scanner object. Let's call it scanner. User input equals new scanner system.in. We'll prompt the user's input. We'll say, please enter the number of lines. And then we'll assign a variable to that. So we'll call it num lines user input dot next int, which takes the integer in the input. Now, our for loop, we'll just do for. As we mentioned, int I equals 0. I will go up to the number under the number of lines, so less than, not less than or equal to, num lines, and I plus plus. Again, let's just write it out again over here so that we understand what's happening. We're going 0, execute, 1, execute, 2, execute, and 3, execute. And we're stopping. We're not going up to 4. That's 4 lines right there. So now we know what this for loop is doing. And then we'll do the for loop that's inside of it. Well, we know that this for loop needs to output a new line, so we'll just do sysout print line. And then we'll do for int j equals, as we said, int j equals I, or int j equals, I. And then we'll do j greater than or equal to 0, j minus minus. And then we'll execute something. which is going to be printing out the stars themselves. And don't make a mistake over here. You have to remove the line because we want them to be on the same line. So now what this for loop is doing is it's going in. It's first j is equal to 0. So it's printing out 0 once. It's going to -1, but it's not actually going into the for loop because that's out of bounds. So we're just doing 0. And then we're going 0. We're going 1, 0. Then we're hitting -1, so we're not going in. Then we're going 2, 1, 0. Then we're hitting -1, so we're not going in. Then we're going 3, 2, 1, 0. Here we can see the pattern once again. And now once we run the code, let's say 4 as our example, and we can see the ascending star pattern over here. And if we wanted to do more lines, there wouldn't be any problem. We just put, let's say 6, and we'd have our 6 lines. So now we're going to move on to a somewhat lengthy problem. This problem is a gateway to many problems we'll be seeing regarding for loops, and I can almost guarantee that one of your exam problems will have this problem as part of the code. So the problem asks us to make a program which takes the last letter of each word and capitalizes it. So if we were to put the string, this is a test, it would come out like this. Now, this program has a key concept that we need to understand, which is string traversal. Although you might not get this exact problem, I can guarantee that in your exam that covers for loops, you're going to get one form or the other of string traversal. So let's break down this problem into its smaller parts, right? So what we need to do is we need to plot out the functions of the program. First, we need to take a string as input. We can do this with a scanner object. Then we need to find words in said string. And then we need to finally capitalize the words or capitalize the ends and return. Okay. So taking a string as user input is fairly straightforward. You just need a scanner object and it's pretty easy. The one we need to focus on is finding the words. So I'm going to do something over here just to explain how we're going to do this. I'll write this is a test as a sentence. What I'm going to do here is I'm just going to take out all the spaces. Now it's much harder to find out where the words are, right? This shows us something. It shows us that the way we know where words begin and end is the space. And to make a program understand where a word begins and ends, we need it to be able to see the spaces and take all the characters from the current space to the space before that. So if I were a program, I'd go from here to here to here to here, and then I'd stop, and then I'd take all the characters from this space to the space before it. And then I'll go here, 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 take all the characters from this space to the space before it, and so on. Now, as you might have thought, there's an exception to this. The exception is the last character in the string. Now, the last word in the string. The last word doesn't have a white space after it. There's no space. So how is the program going to find it? Well, it's not. So this is where we can find something called an edge case. So this is one exception in the program that we need to account for. What we'll do is we'll just make a separate if statement looking for if we're at the last character in the string. If we're at the last character in the string, we'll take all the characters from that to the last white space, and that's how we'll account for the last character in the string. Now, how I'm going to do this code is ignoring commas and periods. So if your professor asks you to account for commas and periods, you can solve that by using a simple if statement and scanning the word. You'll see if there's a comma. If there is a comma, you'll just go to the character before that and fix that character and then send it over to the output string. You'll understand once we do the code. Now, let's move on to the code itself. So first, we'll do the scanner and the stuff with all the scanner's input. So we'll do scanner user input equals new scanner system.in. And then we'll prompt you the user input. We'll do please enter a string. And then we'll assign a string variable to that. Okay, now we need to assign the variables that we're going to be using inside and outside the for loop. As we know, for loops have a specific scope. So if we assign a variable inside the for loop, the program can't see it outside of the for loop. So all we're going to do here is initialize the variables that we need to use once we're done with the for loop. So the output, we'll call it output. We need to use that outside of the for loop to show to the user. So we need to initialize it outside the for loop. And then we'll do this over here. What we're gonna do is we're gonna make a variable called last white space. As I said, we need to take all the characters from our current white space to the white space before it. So in the beginning, the last white space we know of is the first index, which is gonna be 0. So we'll initialize this value at 0, so that when our program is going through the text over here, let's look up here, we'll do 1, 2, 3, 4, stop here, and take everything from this to the last white space. On the first traversal, or the first word, the last white space is going to be 0, so it'll take everything up to the beginning of the string. And then we'll reinitialize the last white space to be over here, and we'll move on, and then we'll take everything from this white space to the last one, and then we'll reinitialize this, we'll move on, and so forth. So this is what's called fence technique or something, I'm not sure, but it's called fence and fencing. You'll probably learn it in your lecture briefly in one of the slides, but you don't need to know the terminology. You just learn how this works and string traversal in general. Now let's move on. We'll do the for loop. We'll do for int I equals 0, I less than user string dot length with parentheses, and then I plus plus. Okay, so let's discuss why we used everything we did in this for loop. Int I equals 0, we're starting at the first index of the string, 0. Then we'll do I less than user string dot length, not less than or equal to. Now why? First of all, user string dot length with the parentheses are very important, because without them, you'll get an error. As you'll see here, you'll get an error because without the parentheses, you're requesting the length of an array, not of a string. So now we have a squiggly line, you're going to get an error if you run the code. So the parentheses are very important. Let's see why we used less than and not less than or equal to. So first we're going 0, then 1, then 2. Let's say the length returned 4. Let's say the string was just test. Length is going to return 4, which is the length of the string. It's 4 characters. However, if we go all the way up to 4 in the traversal, we're going to go from 0 to 1 to 3 to 4. If we look up here and count the indexes, which is what we're traversing, we're going 0, 1, 2, 3. There is no fourth index. So if we go all the way up to 4, we're going to get an out of bounds exception. So we want to go up to 3 and stop. That's why we'll do less than. Try it for yourself. If you go less than or equal to, you're going to get an out of bounds exception. I'll show you at the end. We'll do it at the end. But now the code isn't even done. So what we'll do is we'll do car, current character, we'll call it, equals user string dot car at I. What this is doing is it's fetching the character at index I. So let's say we're at 0. It's going to fetch this character t and assign it to current character. Now, this is where the traversal starts. So string traversal, what it is essentially, as we mentioned, it's going over the string. So if we're looking at it from the program's eyes, let's say we're traversing this. This is a test over here. This is what the program sees. T, then it sees H, then it sees I, then it sees S, then it sees the space, then it sees I, then it sees S, then it sees the space, then it sees T. Yeah, you get what I mean. I'll go back to OneNote for a second just to draw this out. So let's draw out string traversal just so we can completely understand it. We have this, or let me just... This is a test. So what the for loop is doing is it's starting at this character, it's stopping, it's executing a certain function inside the for loop, then moving to this one, stopping, doing whatever it needs, moving to this one, moving to this one, moving to this one, and so forth. And every time it stops, it's executing whatever's in the for loop, then moving on. Executing, moving on. So that's how we traverse the string and stop at each character within it. Okay, now we're back here. So what's next? Now that we've assigned the character and we have it stored in a variable, what do we need to do? First things first, before we do the normal case, which is finding the space, we need to account for the edge cases. Edge cases are always accounted for first. So we'll do if I, which is the index, equal user string dot length minus 1, we'll do something. What does this mean? So if I is at the last index of user string, so minus 1, because as we said, the length returns the length in numbers, and we need to get the last index. So if the length is 4, the last index is going to be 3. So we'll do minus 1. So if I is at the last index, we know that we're at the last word and we want to fetch the last word. So what we'll do is we'll grab the last character of the word, which is going to be current character. We'll make a version of it that's capitalized. So we'll call it car, current character capitalized. We know that the current character we're at is the last character. So we can just go ahead and capitalize it right off the bat. So we'll just do character dot to uppercase current character. So what are we doing here? Again, let's write it down. So we have this is a test. So in this edge case, or this if statement, we're at the last word. So we stopped over here since we're at the last index. And we know that this is our current character right now, this T. So what we're doing is we're grabbing current character capital, or grabbing current character. We're making a new version of it called current character capital, which is capitalized. So the current character capital right now has a capital T stored in it. Then we'll make a string called current word, so the word we're currently at, and we'll make it user string dot substring last white space to I plus the current character but capitalized. So what have we done here? Now we know that user string dot substring or substring is exclusive of the last index. So by doing last white space up to I, what we're doing is we're grabbing everything from this last white space. So let's remove everything. We're grabbing everything from that last white space up to this S. We're not grabbing the T because it's exclusive. We're telling it to go up to I and stop. So it's not taking I. And then what we're doing is we're adding the capital T. So now our current word is this, which is the word with the capitalized end. Now that we've accounted for our edge case, let's move on to the normal case. But we need to do one more thing, which is add it to the output. So we'll do output plus equals the current word. So this is adding it to the output string. Now, let's account for our normal case. Else if character dot is white space current character, then we'll execute this. So now we're looking for white spaces now that we've accounted for our edge case, which is the last case. So int index of last. Okay, I just want to mention one thing. If you found this edge case to be confusing, try to make the code without the edge case. Just go directly into the white spaces, and you're gonna see that you're gonna be missing your last character, your last word. Then it should become much clearer why we need this edge case and why we need to put it before the actual normal case. So what we'll do here is we'll do int index of last end equals I minus 1. I'll explain what I mean in a second. And then we'll do current car equals user string dot car at index of last end. What does this mean? So here, unlike the first one, we're not stopping at the last character, we're stopping at the white space. So to take the last character, we need to go back. Let's write this out again. So this is a test. Let's say we're scanning the first word. So the program is going from here to here to here to here, and here it's stopping, right? It's stopping at this. Now, if you wanted to capitalize the last character of the word, we need to go not I, we need to go I minus 1 to be at this over here. So that's why index of last end is there. Last end, I mean like the last character. So index of last end character, you could call it. Index of last end. That's why we're doing I minus 1, because we're stopping over here, and then we're moving back to the one over here. And then we're making a capitalized version of that. First, we're reassigning current character to this instead of the white space. And now we're going to make a capitalized version. So we'll do car capital equals character dot to uppercase current car. And now we've stored the capitalized version of that character. So let's do string current word equals user string dot substring last white space up to I minus 1. Again, we're doing I minus 1, not only because it's exclusive, but now we need to cut off the last word. So again, we'll go back up here, look. So I is here at this white space. We're going I minus 1 over here, and dot substring is exclusive, so we're also going all the way back here. So what we're doing is we're clipping off the S, and we're just doing THI. And now what we're going to do is we're going to add car capital. So it's the same concept as what we did in the edge case. And now we're adding the capitalized version of the last character for a final current word of this over here. And then what we'll do is we'll reassign the last white space. As we mentioned, we're traversing. So if we're starting the traversal at, as I initialize it over here, last white space equals 0, we're going here, then here, then here, then here. Then we're taking all the characters from the current space we're at up to the last white space, which is 0 at this case. But now we're done. We took the word and we added it to the output. We want to go to the next word. So we need to reassign the last white space to this white space because we're going to leave it and we're going to go to the next one. So this is going to be the last one. So what we need to do is make the last white space our current index so that we can move on. And then we'll add the current word to the output. Okay, now we're done with all that, and then we'll just output the output and close our scanner object. Okay, now let's run the code and see how it works. So we'll do this is a test, and as we can see, the ends of each word is capitalized. As I said, I'm going to show you what happens if you have an out of bounds exception. So over here, if I were to put I less than or equal to, what's going to happen is I'm going to enter the string. Over here, we got a bunch of errors, but the main one says string out of bounds exception. Index 14 out of bounds for length 14. Length 14 has 13 indexes, not 14 indexes. So we just need to remove that equals. And then let's see what happens if we didn't account for our edge case. So we'll remove this edge case that we accounted for and we'll remove the else. We'll run it again. This is a test. As we thought, the last word isn't present in our output. And that's why we always need to consider edge cases. I think it's when you're actually doing the problem, you need to just make a rudimentary outline or code and then see what doesn't work and then account for the edge cases. I just guided you step by step because I already knew the edge case was coming. But if it was my first time doing this problem, I'd probably make that mistake and have to account for the edge case after making the mistake. But that's fine because that's how problem solving is. Alright guys, I hope that was helpful. If I find that there was a high demand on this video, I'll probably make a separate one with more problems on for loops. Again, if you have any questions, you can always email me down below. My email is in the description.